Hello everyone, my name's Jim, and I'm hosting today's Tech Thursday. This sounds kind of familiar to somebody else that I know, their intro. Hope it's not copyrighted. Alright everyone, so what I'd like to do today is, for this Tech Thursday, I'd like to show some of the tools that I use to forecast hurricanes. I've been using some of these tools for a little while. Some of them are newer, some of them have developed over the years, and some of them have been around for quite a while. So basically what I want to do is I want to take a look at where the storm is right now and get some of the details. And of course, one of the first things I do is I go out to the National Hurricane Center and look at the latest storms. The storm that I'm going to look at right now is Hurricane Dorian. Right now it's near Puerto Rico. Today is August 28th, and I'm going to take a look at Hurricane Dorian and some of the details that the National Hurricane Center has put out. Looks like the latest advisory was at 11 a.m. Atlantic Standard Time. Gives highlights of what's going on, hurricane conditions. It gives a brief synopsis of what's going on and what's to be expected within the next couple of hours. It talks about rainfall, wind, storm surge, those parameters right there. Gives a little bit of the graphic to kind of give you a thumbnail what's going on, basically the 5-day track, the expected winds, what time the tropical storm force winds may be impacting certain areas. So I'll take a look at that kind of information, just kind of get me up to speed on where the hurricane is right now and what the conditions are. Some of the other products from the National Hurricane Center that I'll take a look at is the text products. The public advisory is usually a good one. That's the one where they make it very non-technical and break it down for the public. And there will be its current location, all the parameters, wind speed, so on and so forth, the movement, any hurricane or tropical storm warnings, watches, advisories, things along that line, the extent of the watches and the warnings, and then what to expect. Forecast discussion, a little bit of an outlook, what areas are going to be impacted, and also, very important, is when the next advisory is going to come out. That's what everybody wants to know. That's one of the products I'll look at, is the public advisory. And if I want to get more technical details of what's going on in the atmosphere, I'll go to the forecast discussion. Here it's a little bit more technical. It's meant for atmospheric scientists and meteorologists. They go into more in depth what the hurricane hunters are finding specifically inside the eye, you know, what kind of development's going on, any winds that are going to be translated down to the surface, intensity forecasts, so on and so forth. So I'll look there, and that kind of gives me an idea of what their thinking is, along with what the real-time observations have been. Another product I use is an oldie but a goodie. It's the spaghetti model plot. Everybody probably knows the spaghetti model plot, and that's the one where you got a whole bunch of lines that are nested together right where the hurricane is, and then within a matter of a few days, it goes all over the place. So as you can see from the spaghetti model plot of Hurricane Dorian, you can see that a lot of this information here is from model runs, an observed path right now, and if it continued on that path, what would it do if it just kept propagating out. But basically, if it's within a 12-hour time frame or so, they'll have pretty much the same idea from run to run, and then each model tells its own story based on its own modeling physics. So as you can see, it's starting out somewhere southeast of Puerto Rico, and then looks like it's going to take a forecast track moving north-northwest, and then eventually most models tend to go ahead and curve it off to the west. And part of that, which reading from the forecast discussion, is a strong high pressure system is going to build off to the north, and so with high pressure systems in the northern hemisphere we have clockwise rotation, and so therefore a hurricane doesn't want to go straight right into the high, so what it's going to try to do is it's going to take the path of least resistance and curve around. So that's why the modeling is indicating that yes, this high is going to form, it's going to park itself here at about this time frame here, and it's going to start to curve it, and it looks like it's going to curve it toward the Florida Peninsula. So basically, there's two reasons why I want to see this product. Number one, it tells me when I look at this from run to run, I see consistency in the models. Is one model all over the place, or are they all converging on a consensus that, yeah, we're pretty confident this is the way it's going to go? Even though each model has different modeling physics, as you can see, they're kind of bundled pretty tightly here. In the next 24 to 48 hours, that means that even though each one's got slightly different modeling physics, it looks like that's a pretty strong indicator that that's where it's going. As well as anything could happen, because as new things form that the models have not forecasted for, that could alter the track a little bit. And as you know, anything weather, if something's off by 5, 10, 20, 30 miles, it drastically affects things. Especially with larger hurricanes, you could be right on the edge of where hurricane force winds could be. You could get something stronger within 30 miles, or you could get minimal tropical storm force within 30 miles, depending on how strong the hurricane is. So it makes a big difference. One other thing that I want to point out is you will have the occasional straggler. And again, going back to run consistency, we'll see that this model here, we'll see when the next model run comes out for it to see if it gets in line with the rest of these, or if it's just thinking that, no, there's something else here. So we don't discount each model altogether just because it's an outlier. We look at it and we take that as information to go, okay, maybe it's trying to tell us a story that something else might be going on. Most of the time the outliers do wind up being wrong, but we do have to consider it when forecasting. Because if this, in a few days, all of a sudden becomes this, then we've made warnings and watches for areas, and that increases our bust factor, and people won't rely on our watches or warnings or take them as seriously. Okay, so now the next products I'm going to take a look at is the GOES satellite products. And what I want to do is I want to start out at a zoomed out level. Basically what I'll do is, from this very zoomed out view, is I'll take a look at where the storm is, and it helps me identify what direction it's actually moving in. Right now it looks like it's kind of moving to the north-northwest, but with understanding the way hurricanes form and the way that they develop and expand, you kind of have to look at each storm and see, is this just naturally blowing up and it shows movement, or is it actually progressing, and as it's progressing and blowing up, it's kind of misleading as to what the movement actually is. So it's just giving me basically an idea compared to other land masses. Puerto Rico's here, we have Haiti and the Dominican Republic here, we have the Southeast United States over here, and you can kind of see it is inching its way off to the west, northwest. I also look at this to see trends for other upper level troughs that are steering it. Do I see clouds out ahead of it? Where are they moving? Because as this gets over there, what is the dominant atmospheric feature that's occurring here? That'll also help inform me as to where the storm is going to go. So what I'll do is I'll actually choose another product that zooms in a little bit more, and unfortunately this one does not have latitude longitude lines, but it gives me a better representation of, at this point, the Eastern Caribbean. And as you can see, some of these features are becoming more defined. We have some stuff coming off the southeast US coast. We have some other things, other circulations and other atmospheric phenomena going on right now. So we can see that the hurricane is trying to edge up. Looks like we've got a lot of stuff moving up to the north right now over this area here, and so it kind of looks like the hurricane is kind of inching in that direction. So that helps me kind of zoom in a little bit from the larger picture to like a medium-sized regional picture and see what's going on. I can pick up some more details because I'm not so far zoomed out. Next thing I'm going to do is zoom in even further. This is a little different than what you saw earlier. This is a water vapor image from the mid-level. Basically what I'm looking for here is there any dry air that's being entrained into the storm that'll help disrupt it a little bit? Or does it have enough moisture with it that it's going to sustain itself and grow? So as you can see here, the core of the hurricane is somewhere in this area. Looks like it's got plenty of moisture. It doesn't look like a whole lot of dry air is being wrapped in. Again, it doesn't look like it's really moving that fast because the update, it's updating, it's a loop of 1 frame per minute, and I've got about 3-hour loop right now. So it doesn't look like it's going too far, but I can look at where the mid-level circulation of the hurricane is and kind of estimate, yeah, it looks like it's actually moving a little bit west-northwest, whereas on the larger views, it almost looked like it was moving north-northwest to almost due north, where the actual center of the circulation is actually moving more this way, but the upper level clouds are moving more like that. So if I go back to the models now, I can take a look at the storm. Is the storm moving similar to what these models are showing, or is it moving a little bit differently? When these models initialized, did they initialize the storm to be too far north, too far east? That plays a role as to the eventual path of the storm. One of the other products that I like to see is forecasts from some of the hurricane models. This website here allows me to take a look at one of the hurricane models and put it into animation and to see it move along. Basically, this model here makes it storm-centric, and the geography kind of rolls underneath it. With it being storm-centric, you can see intensity, feeder bands. You can also see variations in the pressure. You can estimate winds from that, and also what interaction with any land masses that there would be. So there you have it. Those are the basic products that I use to get a good understanding what's going on and make my forecasts from. There's other products as well, but those are the foundational ones that I've found that are tried and true and help me out a lot. So I hope you really enjoyed this week's Tech Thursday. Changed it up a little bit, trying to compete with Kayla a little bit.
No, he's not.
So if you like this video, go ahead and give us a thumbs up. And don't forget to subscribe down below. You can also check out our Instagram and Facebook right here. All the links and everything else will be down in the description below. Until next time, I'm Jim, and happy hurricane forecasting. Okay.